Hello, I'm happy to introduce datagen, a tool we built at Dream11 to solve the problem of creating coherent synthetic data at scale for us. Datagen is a simple DSL that allows you to encode the schema of the entity that you wish to generate the fake data for. You define the fields that your entity has, and the generator functions with the logic to create the data, and datagen does the rest. Now, there are a lot of tools to create one-off fake data. If you want a list of 1,000 fake email IDs, that's easy. Where datagen really shines is when you want to create data that is coherent across several entities. Consider this basic example. You have a company entity and you have a product entity that has a reference to the company entity. You could also have a user entity and an order entity that has a reference to the product and the user entities. Now, the data for these entities cannot be created in isolation. They have to be created in tandem for the coherency to hold. The orders entity ought to have valid references to real products and users. On top of that, you might have business rules that need to be respected. For example, some products might not be available to some users. This could be on the basis of the user's age or their geographical location, say. Modeling these business rules can get gnarly real fast, and this is exactly where datagen shines. Now, I have spoken for far too long without showing you any real code. Let me change that. Let's create a very simple users model. It has to go in a DG file with the same name. We use the model keyword followed by the model name, which is users in our case, and enter the body of the model. Datagen code is built up of sections, and here we enter our first section called the field section. In the field section, we define the fields that our user model has. So it has a name, which is a string, and an age, which is an integer. The next section we need to define is the gen section, which has our generator functions. Each generator function is a valid Go function, but with two special behaviors, which I will talk about in a bit. A simple generator function can return hard-coded values for now. Let's create a generator function for the name. We can use the value John Doe for the name, and for age we can use the hard-coded value of say 42. Alright, so we have defined our users model now. We can generate the data for this model and see that it works as expected. Okay. Recall the two special behaviors that our generator functions have. Let's go back to the users model to see the first one. Introducing the iter variable. Let's add a new field to the users model called id, which is an integer. We'll have to define a generator function for id. Now each generator function gets access to an integer parameter called iter, which represents the row number that the generator function is expected to return. Iter is 0 indexed, so say if we wish to have id starting from 1, we can simply do return of iter plus 1. This will give us values starting from 1 with one-step increments. Generating the data again, we see we get the id. Let's do 10 rows. We can see that the id is incrementing from 1 onwards as expected. Now we have hard-coded values for the name and age. Let's change that. To make the data dynamic, we can use the standard library functions that datagen has, replacing the hard-coded value with the standard library function name, which returns fake names, and int between, which returns a random integer between, let's say, 20 and 60. Okay, so we have random names and random ages, and the ID remains as is. We can do JSON as well. Alright, this works as expected. Now on to the second special behavior of the generator functions. This relates to how we can access the data of other models in the generator functions. Datagen allows you to access arbitrary rows of arbitrary fields of arbitrary models in each generator function. Here we have a new model called user country, which models an entity storing where each user lives. Let us update the code in the user country model with actual references. Here we need a valid reference to real user ID. To get access to a real user ID, we can use the following syntax: self.datagen dot model name, which is users in our case, dot field name, which is ID, and then we can pass the iter to get the first user, for example, for the first row of user country. And we can change the hard-coded value to use another standard library function called country, which gives us a random country on each row. We also need to move our users model into the models. So now our models directory has two models, users and user country. Now this is a somewhat contrived example, but let's see what the data looks like. This time we can stop at just the transpilation. Why are there no exec flag? We can go to the transpiled code. We can build it. And now we can use the datagen binary to generate some data. Of course, the right syntax is to use gen. So now we see data for the user country entity and the users entity. The user country entity has valid references to the user ID, and we get a random country for each user. This concludes the basic introduction of datagen. There are a ton of additional features you can check out. Loading of generated datasets directly to the database, tags to group and filter models, nesting models in directories to organize them, for example, by services or teams, a miscellaneous section for custom types like structs for creating JSON values, a call section for passing state variables to generator functions, setting the seed for deterministic data generation, and much more coming in the future. Please let us know what you think about datagen and do start the repo if you like it. Until next time.